Hello, ROS Developers. Welcome back.
Welcome.
And we are ready to see who is the winner. I have seen a lot of correct answers very fast, but only can win only one, the first one.
Yes.
And then the first one who did it, who said correctly, is Thor Panbil, who mentioned a universal robot. Yeah, so universal robot, UR5, all of them, they are correct answers. So very good, very good. So then Thor, our team is going to contact you to get your details, and we will send you the T-shirt and the mug, sponsored by Robotics. Great.
Congratulations. So our next keynote speaker is Yutaka Kondo. Yutaka is an engineer at Preferred Networks and the author of the first ROS2 book in Japanese.
Yes, it's awesome. The first ROS2 book, it was created by Yutaka, and he has delivered this material to the ROS community, of course. But apart from the book, so one of the points that the ROS community lacks is the number of robots that work with ROS2. So Yutaka is going to attack this point here today, and he's going to talk about how to build your own ROS2 enabled robot from scratch. Welcome to the conference, Yutaka. Konnichiwa.
Konnichiwa. Hi, everyone. This is Yutaka Kondo. Can you hear me?
Yes.
Clearly?
Everything
Okay.
perfect. And the audience is all yours.
Okay, so let's get started. So again, thank you for inviting me as a keynote speaker. I'm very happy to be here today. My title is Build Your Own ROS2 Robot from Scratch. Today's goal is to build your original ROS2 arm robot from scratch. Build from scratch means from the CAD model designing to the ROS2 application programming. Once you have understood my presentation, I hope you can build your original ROS2 robot by yourself. There are 4 steps. First, prepare the URDF file. It's a robot description format. We will make it from the CAD model. Next, update the URDF to satisfy the ROS2 control framework. Third, you use the URDF to the ROS2 applications with the dummy robot. Or finally, run ROS2 application with the real robot. Again, I'm Yutaka Kondo from Preferred Networks. My user account is usually Utalk. It's Yutaka, And I have a GitHub, LinkedIn, and also Twitter account. So if you have interested, please follow me. And the company webpage is shown here. In addition, I'm an ex-organizer of ROS Japan users groups and program committee member of ROSCON-JP. ROSCON-JP is an official open robotics franchised event of the local ROSCON. This is the webpage. In addition, I'm an author of the world first ROS2 book named ROS2 Hajime, or Getting Started Next Generation Robot Programming with ROS2. It's written in Japanese, but I'd really appreciate it if you are interested. Please check it also. Let's get started with my presentation. First step, prepare the URDF. This is the robot pan tilt bot we would like to build from scratch. The pan tilt bot is an MVP, minimum viable product of arm robots. It's a very tiny robot, but it has joints and a sensor. It has 2 degrees of freedom and the inter-rear sensor on top of the arm. Robotics dynamical motors are used for the joints. The CAD models of the motors and the hinge frames can be downloaded from the Robotics Download Center. And next, next step is design your own arm robot. First, I use Fusion 360 for the 3D CAD software, so it has a personal license for hobby use and it's free, totally free, so you can use it on Windows OS or Mac OS. Next, design pan tilt bot. First, import the motor step file and the hinge frame step files from the download center, which I mentioned before. And then connect them using 2 rotational joints and 1 fixed joint. Be careful that you must rename the root link to base link due to the ULDF exporter's restriction. Next, convert that CAD model to ULDF. First, you need to install the ULD exporter for Fusion 360. It's a Fusion to ULDF. It's very useful and it can convert the Fusion 360 model to the ULDF model directory. I have a video for the designing and exporting within 6 minutes, so let's see it. This is the parts which we used and new design making, and also save the punted board for the name, and then import the motors. It's a joint 1, I mean the root joint of the robot, and locate the appropriate location. And next, import the joint 1 hinge part to connect to the joint 1 part. Using assemble system, the connecting the hinge and motors by the rotational joint look like that. And next, import again the servo motor for the joint 2. And next, fix the hinge to the joint 2 with the fixed joint. Finally, import the hinge joint for the joint 2. It will be the rotational joint for the joint 2. Look like that. Next step, if you want to rename the joints and links, please rename it like that. First, break link is required to for the ULDF exporter and rename it. Be careful again. The joint name of the root link is to be the base link. Skip. And lastly, you need to limit the joint angle range. You can input the maximum angles and minimum angles like that. This is it. Finally, the robot is made it. And save here. And next, the exporter stage using the add-ins. And if you install the ULD exporter, you can run it and select which direction. Successfully create ULDF file. You can see it. And be careful, don't save the model because the URLDF exporter modifies the model, so you don't save the model. The result is shown here like that. Okay, go back to my presentation, and note that the Fusion 2 URDF exporter can only export ROS1 format, so I need to migrate into the ROS2 format. And the original PanTiltBot, no. Original PanTiltBot file is located here, notebook workspace. But I can use for the ROS2 description, it's the meshes directory and also the some of the CMX and package. And also URDF is you can use it. We only use meshes directory, as I said, and also we need to migrate package.xml and CMX list. I explain about it. Package XML is shown here, and you need to change the package dependency to the ROS2 package, just like that. And also virtual is CMake. And next, CMake Rix is also changed to, you need to change the ROS2 format like that. I think you can simply migrate into ROS2 format. And the final ROS2 PanTiltBot description with ROS2 format is located here. This one. This is it. So next step is attach the interior sense sensor on top of the robot. My design has no real sense on my CAD model, but the real sense 2 description package contains the 435i URDF file, and also it is Chakra format, so you can easily integrate the sensor into my robot. The final version is here. You can import the sensor D435 Chakra tag to locate here. The origin XY and RPY is shown here. The next step is to enable ROS2 control. First, set up ROSDevDay, this workspace for ROS2 Foxy. When you launch this ROSDevDay, run once the command below to completely enable ROS2 Foxy environment variables. Copy and paste. And relaunching the terminal unit. After relaunching the terminal, you can see the ROS environment variables like that. Next step is build package. First, clone the dynamic cell control repository. It contains ROS2 control implementation for Robotics dynamic cell motors. This line shows the clone the dynamic cell control with ROSDevDay 21 branch. The branch used a fixed version of the ROS2 control packages because the ROS2 control packages are still under heavy development and they can break the API compatibility. That's why I fixed the version of ROS2 control. And next, install the dependency, but currently my ROSDevDay already installed the dependency. So, and also build the source code, but let me check them. Only this Qualcomm build. And directory ROS to workspace and no, yeah, this one. Wait a few secs. And successfully built. And also, I need to explain about dynamic cell hardware. This is the dynamic cell control repository has a dynamic cell hardware package inside, and it is the system interface implementation of the ROS2 control for the multiple robotics dynamic cell motors. If you are familiar with ROS1 control, the system interface looks like a robot hardware class. It's a plugin dynamically loaded by the ROS2 controller on runtime. And also, the dynamic scale hardware package is hopefully compatible any configuration of robotics dynamic scale submotors, thanks to the ROS2 control's flexible architectures. Next step, you need to configure the ROS2 control plugin. This is the ROS2 control plugin configuration, and USB port is the dynamic motors serial port, and baud rate is I just set the 100,000 hertz, and also my robot has 2 degrees of freedom, which is this is their joint ID are 11 and 12. And first, I need to use it for dummy mode, and it is the use dummy tool. The dummy use dummy the use dummy parameter is required if you don't have a real pointed board, and it is also very useful while you are in software development. You don't need to install extra software such as the gazebo simulator. Next, you need to also configure ROS2 controllers plugin. You can use the velocity controller for the velocity control and the joint trajectory controller for the position control with interpolation. The joint state controller published the robot's current joint state, which contains the position, velocity, and effort for each joint. You need to describe the velocity control parameter, look like that, the joint list, and also joint trajectory controller is required to the joint list also. The joint state controller is not required to input the parameters so far. Next step, if you've successfully built them, the result of following command shows the ROS and GUI window. Let's run this command. First, sourcing the local setup, and next, launch the display launch Pi. This launch Pi visualize the ROS to this window, and also the joint state GUI. It's the virtual joint controller. This is for joint 1 trajectory, and also this is the joint 2 trajectory. X looked work properly, so it's okay. And I want to share the display launch by. What is it? The Puncture bot launch display launch.py has 3 nodes. First one is joint state publisher and also RVS2. And you need to launch robot state publisher also. It is the published robot description which we made before. Next step is run ROS2 applications. The first application is ROS2 command line interface and also RVS2. First, launch the ROS2 controller and load the follow join trajectory controller and also velocity controller. Please follow the command. Wait a sec. Also launch the launch by. This is not the same display launch by, but bot launch by has several nodes and commands, so I need to show them. This one. You need to launch the controller manager of the ROS2 control with the robot description parameters. And also, you can execute process, not only the node. So I launched the controller command to load the joint state controller and velocity controller and joint trajectory controller. And also, you need to launch robot state publisher. And if you want to visualize the robot, you can launch RVS2 also. Next step. So you and currently the ROS2 controller already loaded the 2 controllers. First one is a velocity controller and also follow joint trajectory controller. So you need to switch controller to start one. The first, sourcing the local setup and this command result the successfully switched controller to the joint trajectory controller. Next step, it is the official controller interface for ROS2 client library. Command line interface, sorry. And next step is the sending follow joint trajectory action go by ROS2 command line interface action interface. And this first, you need to source the local setup also. Next step is ROS2 action send go. This is whole things. You need to copy them, all of them. And finally, the robot will move like that. wait a sec. This action command means the trajectory has joint names and points values, and the points has a lot of positions lists, and it has the joint angles, and time from start means the start time from 0. So this data is elapsed 10 seconds, almost 10 seconds. Let's try. So that is a dummy mode effectiveness to use not only not use simulator or real robot. It's a very simple way to test the robot programming correctness. So once you have robotics dynamic cell hardware and the painted bot description for the ROS2 package format, you can easily apply them to the Movie 2 and Gazebo simulator. But it is very no, sorry. I have no time to explain about it, so please try for your next step. This is the link for the Movie 2 and Gazebo ROS to control connection. Next step is the run with the real robot. So this step, we need to use the real robot and set up on local to follow the this build package sequence also. And next, the disable use dummy parameter. So this is my local PC terminals, and this is I commented out the use dummy, or you can specify as false or not, or comment out. And the command is the same as the dummy mode terminals. Look like that. This launch file and visualize the RVS2, and can you change the my display for my web camera? Can I do that, or you need to?
Yes, we are doing this.
Thank you very much.
Yes, sure.
So,
yeah, you are online, so now you can see. We can see you.
This is my tiny robot. Can you see it? Okay. The web camera.
Yes, we can
view.
see.
Okay, thank you very much. This is tiny robot, but enough for the ROS2 robot. And next step is switching controller to joint trajectory controller, and send the action go. So the robot moving around as same as the dummy mode. So I have one more controller, the velocity controller. No, switch. I have one more controller. It is the velocity controller, so I can use it to switch the controller for the velocity controller, and then publishing message. This is the joint velocity of the joints. It means the 0.1 degrees radian per sec. The robots slowly moving around and opposite side. That's it. So this is my presentation. So if you want to view the robot on your ROSDevDay, I can share you the YouTube video so you can see it also. This is the same situation of the real one.
Great, excellent.
Yeah, thank you for listening. It's done.
Very good. Thank you very much, Yutaka. Thanks a lot for your presentation. I know
Yeah.
that the audience really appreciate that some of the presentations, they are based on the real hardware, because we work a lot during the conference by using the simulations and one or another presentation based on real robot is awesome. And having to seeing this in real time at your home, it's also very, very interesting.
Thank you very much.
Yeah, so now let's go for the questions for you. And then for the audience, if you have any question, go to the questions tab that is located on the conference panel. You can put your questions or vote any of the questions that somebody else has put it there, and I will be asking those to Yutaka. Okay, and then in the meantime, let's go because there are already some of them. Then here, the most voted one by Meg Rob that says, any thought in enhancing robot modeling in ROS to include robot with a general closed chain and robot with flexible soft links?
Yeah, it's a very important question, and it's very difficult to realize the cross chain because the IK, I mean inverse kinematics, is difficult to solve by the default IK solver. So I hope some of the simulator can solve the IK of cross chain, so you can use it. And if you want to use the cross chain, the URDF has a mimic joint or fake joint. I forgot the real one, but to realize the cross chain, but it's very difficult to mimic the real movement.
Yeah, that's right. Because actually the URDF is not prepared for that.
Yes, exactly.
Yeah, the SDF it is, but the SDF is used in the gazebo simulation, but not in the models that ROS uses internally.
Yeah, exactly. So, I hope I want to use the cross chain for some of the legs movement or like that, but I think we cannot use in usual.
Okay. Then let me see here. There is another question from Sam that says, if I want to use other motors instead of Robotics dynamic cell motors, what are the additional steps that I would need to take to enable ROS2 control?
Yeah, it's good question also. And yeah, exactly. So you need to use the exact system interface of ROS2 control for the specific motors. So in my case, I use Robotics dynamic cell motors, but if you want to use another motors or another robot, another protocols, you need to implement or you need to search the repository of GitHub, I think.
Yes, exactly.
And the ROS1 control hardware interface implementation, I think you can find them. So you can migrate into ROS2 format. So I can help you. I can help him.
Okay. Then, Sam, I think that this is an invitation to send him a question on email and then continue the discussion.
Yes, please.
Great. Yeah. Then we have another question from Marcos Barrera. He says, is there a URDF exporter for SolidWorks?
Yeah, exactly. So the Solidworks has also URDF exporter, and it's an official one. So it is made by Solidworks, so it works fine. So you can use it.
Great.
I can share the link later
Okay,
for the
great.
Marcos.
Yes, please, if you can share it on the chat once you finish your presentation, that would be awesome for the audience.
Thank you. Yes.
Okay. And then let me see another question. Okay, let me see. We still have time, right?
Yeah, we have so many interesting questions.
Yeah, there. Okay. Okay, so this one I think is interesting, so you can provide your opinion. It's from Anuba Dogra. And then he says, what is the benefit of controlling the arm with ROS2 instead of ROS1?
Yeah, it's a good question. The Sid explained the security and also the robot needs security. And so if you have no security, the robot can move without you. So it is very dangerous. So I think you need to use ROS2 for security. And ROS2 also have embedded hardware compatibility. So if you want to use the raw computational hardware, you can use ROS2. I prefer to use ROS2.
And I would like to add also about in case that your robot needs to have real-time control. So
yeah, exactly. So the part of ROS1 control has also real time, but the whole system of ROS1 is not has real time compatible. So you need to use for the real time is ROS2.
Great. Great. And then let me see another question. We still have some time. Okay, so Marco Arruda is asking why to use URDF instead of SDF that we mentioned.
So it's good question. And the URDF can be converted to the SDF. So if you use URDF, you can use SDF also. So that's why I use URDF directly. Is okay?
Yes, sure. It's okay, it's very clear. And then let me see here some other questions. I'm removing some because I don't understand what they are asking. But okay, so since you have written this ROS2 book, the first ROS2 book of the world, then let me ask you this question by Elena Ebikefe. I think you can provide this because it's basically an advice. Then she asks, what advice would you give to a new ROS developer that is confused?
So please watch the repository source code directory or read me. But currently, ROS.org web page has tutorial for the ROS2, and it is very contentful for all of the ROS2 concepts. So you can first watch it, read it. It is without confusion, I
Okay.
think.
So actually, you are recommending that they start on ROS 2 instead of ROS 1?
My ROS2 book has also ROS1 tour section for the ROS2 beginner or ROS1 experience user. So that, yeah, I hope some of you need to learn from ROS1, but I think the currently you can start learning from ROS2 right now.
Okay. Given the current status of maturity, right?
I hope so.
Yeah, yes. And by the way, related to your book, also, I would like to, my personal question is, so have you been updating your book with the newest distributions? Because since you published the first time your book, then many distributions have appeared afterwards. So have you been doing this updating process with your book?
Yeah. Actually, my book is republished for the Roast to Foxy
Wow,
because
wow.
the robot, no, the book was published on 2 years ago. So the time is for the Roast to
Dashing,
出てこない
dashing,
dashing
okay.
is dashing. So it is almost end of life. So I need to modify the source code and how to install it. But I want to add the roster application, for example, move it to navigation to also Smack. Steve's very nice product, and also ignition simulator. But I have no time, so I have a very tiny child, and also I have
Congratulations.
no. But so it is very busy to
I can imagine. I
reverse
can
that.
imagine. I think it's more
But
difficult than ROS
yeah,
2.
but I hope to do that in the near future.
Okay. And then any chance or any plans to include like your presentation about building your own ROS 2 robot to include this inside your book? Because I think that that would be a very nice material for the guys.
Yeah,
What do you think about
exactly.
that?
A very nice advice from you. So yeah, I hope uh, to add my another section for that.
That would be awesome.
Mm,
And
I have the roster migration section for the Roomba driver, control
uh-huh.
driver, but it's not total one. So I want to append the from scratch section. I hope so.
Great. Great. Let me see because so we are. I'm asking you more questions because we are on time, and since that
Thank you.
you finish a little bit more time, so let's use this time to make people to know more about your job. I think it's very interesting and can
Hmm.
inspire others. So let me see if there is any other question that we can ask. Okay, here there is Andres Flores is asking, could you create two different robots in ROS 2 to control them at the same time in the same network? I tried in ROS 1, but it's not possible as far as I know.
Yeah, as far as I know, it's ROS1 can also deal with the multiple controller
Yeah.
in time because the combined hardware, I think it's the class name, combined hardware can deal with the multiple controller on runtime. So and ROS2 has system interface and also actuator interface, which means that each actuator has each system interface. So you can use multiple system interface like that.
Okay. Okay, yes. So then the answer will be yes for ROS2. Exactly. Great. Then I think that we don't have more questions here. And then let's thank the speaker again.
Thank you so much.
Thank you very much.